Do you want to learn how to secure your AWS VPC? If so, this video is for you. For the best free advice on cloud computing and AWS certifications, please subscribe and hit the bell to be informed of new videos every Wednesday. Hi, my name is Michael Gibbs, and I've been working in technology for over 25 years in both networking, security, and cloud computing. And on today's video, we're going to be discussing securing your VPC from the network perspective, or at least things that people would consider the network. And this is one of a multi-part series where we're going to discuss how to secure your VPC, but we're focusing first on the network. We're very enthusiastic about the network as a first place to start for this reason. There's a lot of knowledge on IAM out there. There's a lot of knowledge on what to do on systems, but when it comes to the network, there's really a lot of missing knowledge out there. So we want to start our security series by focusing on the network. I've spent many years working in network. I was one of the original CCIEs back in 2000. So I've been in the networking side for a long time. So today's discussion is going to be focusing on securing your VPC from the network perspective. Now let's discuss the methods that we'll use to secure your VPC. We're going to begin by discussing routing. And then after routing, we'll discuss firewalls. After firewalls, we'll talk about network ACLs. After network ACLs, we'll talk about security groups. Then we're going to talk about host-based firewalls. And then we'll talk about DDoS protection, as well as intrusion detection and prevention systems and how they can be used to secure your VPC. I want to begin with routing. And the reason I want to begin with routing is if you can't reach something, if you don't have access to it, it's going to be near impossible to attack. So if we begin with routing and we can limit who actually has access to the systems, then it will become much harder for others to attack it. So I like to look at my organization anytime I'm designing systems, and I need to determine who needs access to what. So let's say, for example, you've got your data center or on your organization in a hybrid cloud environment, or just your organization which is connected to AWS via Direct Connect, and you've got your AWS VPC. There are certain things in your VPC that only certain users are going to need to access. So don't provide access to the inner workings of your VPC to those that don't need it. So keep only those that need access to it, give them access to it, and keep everybody else away. And how would you do this? Well, the first thing I would suggest is you would take all of your users that need access. First, you need to figure them out. Let's say it's your network operations department. Let's say you've got a dev test group. Let's say you've got another group. Place them each group in their own VLANs. And a VLAN is a way to logically separate different parts of a switch. And there's much more content on VLANs on the internet. You can look at the Cisco CCNA press books. They'll give you a great explanation of VLANs, and we recommend people understand this if they're going to be working with cloud computing. But the point is, create a VLAN for the people, place them in their VLANs. And we're going to do this because we'll give access to those VLANs. We'll create an IP interface in the VLANs, and we'll give access by sending the routes to AWS so they know how to reach back to these VLANs. And we'll give these VLANs access to the routing information to get to AWS, but we don't really need to give that information to anybody else. So through some thoughtful route filtering, we can make sure that only the departments that need to access the cloud will be even able to reach it from a network perspective, long before IAM would ever even come into play. So if we're going to constrain the people by putting them in specific VLANs, which means specific subnets, and we're going to exchange routing information, we've done a lot already just by that simple step to secure the VPC. But we want more than that. So let's say you've got a 200 user network operations center. It's a pretty big knock, but I've worked in organizations that have that. And much more. And so you've got 200 people in your network operations subnet who do need to access the AWS VPC. What happens if their systems get compromised? Now that they have reachability to AWS, they can now attack your VPC. So in order to keep systems from attacking each other with malware or things that can just accidentally happen, let's further segregate the system. So what we'll do by that is we'll basically create something, in the VLANs, we'll make them something called a private VLAN. And what a private VLAN is, as you can see in this graph, if you've got all these users in the VLAN, but they can't talk to each other because the private VLAN functionality means they can't. So now you've got 200 users, one user gets infected with some type of a malware, he can't give it to everybody else because can't reach them. So private VLANs are another great way to go. Now, people don't talk about this a lot these days. It was talked about a lot more, but it's something called 802.1x. It's an authentication form for Ethernet. So I mentioned that first you're going to logically separate them in their own subnets or VLANs, and then you're going to keep them from talking to each other, the users, with a private VLAN. But what happens if somebody just plugs into the VLAN and doesn't belong in that department? They stick a computer or a Raspberry Pi or whatever, and they use that to launch an attack through your network into the VPC. Well, you can't have that. So I recommend the users of your specific accounts that need access to the VPC, specifically the inner workings of it, to use .1x authentication. And really what happens when you plug in your Ethernet port to the network, it'll look at a database and say, this MAC address, the physical address associated with the Ethernet port, is allowed on the network, open the port. And if an unauthorized user tries to plug into the network, they'll be shut down, the port will just shut down. So realistically speaking, by just using the network, we've already talked about a lot of ways to make it much more secure. Now, firewalls. So what a firewall basically does is it builds this strong, secure perimeter around the edge of your network. I like to think of it in terms of like a castle, and the castle has this giant wall around it to protect people, and then they have a moat that's filled with water and dangerous animals. That's that impenetrable force. Well, the firewall is basically that hard exterior shell that you have. And that keeps outsiders out. Now, like I said, you're gonna have to do a lot to protect the inside of your network. Most hacks happen internally instead of externally, and the internal ones are often just accidental. But the point being is you gotta secure the outside before you can even think about securing your inside. And you're gonna do that with a firewall. And there are some phenomenal commercial firewalls that you can use with your VPC. Cisco makes them, Palo Alto makes them, Fortinet makes them, and there's many other great vendors that are there. But these are really strong firewalls. They not only block traffic out, but they're adaptive. They can basically look at traffic that doesn't make sense, and they can generate rules on demand to block things that they find to be dangerous. So commercial firewalls, great option. Amazon has their own firewall, and we'll talk about that in a moment. But the point being is you definitely need some kind of great firewall service. Now, with firewalls, you're going to create a policy, and basically you're going to allow in only what needs to come in. And typically that's often basically TCP port 179 for BGP routing, and it's whatever ports are necessary for your systems, whether they be HTTPS or SSH or whatever is necessary for organization. But basically, allow what needs to come in and block everything else. And firewalls are stateful. Now, I'll talk about this more later, but what happens is when firewalls block everything coming in except for what you explicitly permit. But if I'm a user behind the firewall and I go out to the internet, the firewall looks at my connection. So it says, okay, I know what's going on. Mike's computer is connecting to the internet and he went to this AWS web page. Well, I have to let the AWS traffic back to Mike. Now, it's stateful, so it knows that it's my traffic and it knows that it's my return traffic, so it'll let it through. So firewalls are stateful. Now let's talk about the AWS firewall solution. So AWS has something called WAF, or Web Application Firewall. And what happens is WAF is used as sort of one of the edge devices of your network. It's typically placed on a CloudFront distribution, an Amazon API gateway, a REST API, or even an application load balancer. But the point is that it's placing a firewall on these devices before things can actually get on your network. And it's pretty great because if you're placing it on the edge of the network, it's going to block the traffic long before it even comes in. And WAF enables you to control access based upon a policy, just like any other firewall. Now, WAF does give you some fairly granular access to protect your resources, and what you're doing is you're controlling access with web ACLs, rules, or rule groups. And with web access lists, they really just allow or deny traffic based upon what you want to permit, just like any type of an access list, but these things are stateful. And you'd set up rules, which I described, which just allow or deny, and then you can create something called rule groups, which are groups of individual rules that can be reused in other places. So if you're building a high security network, you're going to be placing these kind of things everywhere. at every endpoint to your device. So anytime you can create rules and then use those same rules somewhere else, it not only saves time, but it eliminates mistakes that could occur along the way. And what's good about using WAF is that it does give you the ability to actually monitor your traffic metrics with CloudWatch because it's an AWS product, therefore it's automatically integrated. So how does it work? It's pretty simple. You enable WAF on the application or device, you create your policy, and then WAF will basically look at your traffic based upon what's going on. And it's going to permit the traffic based on your permit or deny policy. Now, if an attack occurs, you can create new rules to basically mitigate the attack. And because WAF is going to integrate with CloudWatch, you can set up alerts. So you can basically say, create a rule and notify systems administrators so you can do something about it. So in this diagram, you can see what we've done is we basically placed WAF on the edge devices, and we're using that to secure the rest of our remaining network. So let's talk about network ACLs. So we talked about firewalls blocking entry into the network, and we're going to use network ACLs to block traffic in and into the subnets, and out of the subnets for that matter. But the point is, we're blocking the exterior. Now, if something were to get through the firewall, now we can block the traffic with a network ACL. When it comes to security layers, it's like dressing for the cold. People can get through one, but if you've got 40 levels of defense, and you get notified along the way when things are happening, you have time to stop it. So the more layers, the better. In this case, we're using a network ACL. And we're going to allow only necessary traffic into the subnet, and we're going to block it. Everything else. So what we need comes in, we allow, and what we don't need comes in, is not allowed. And by blocking what you don't need, you're really saving yourselves a tremendous amount in terms of being hacked, because if you block almost everything, the only thing they can attack you with is what you're actually allowing in. Now, network ACLs are not stateful like a firewall. Remember I said if I connect to the internet through the firewall, it watches my connection. That's called stateful, and then it allows the return back. Network ACLs are not stateful, which means you're going to have to write a network ACL for outbound traffic and inbound traffic, because it has no means to actually know the way the traffic is coming, because it's not watching it. It's just creating some packet inspection rules, allow, deny, and that's it. So all network ACLs have a default policy, which is deny all traffic. And you're going to build a policy. And when you're doing this, you're going to specify the source and destination address, and there can be some wildcards in there as well, the protocol and the port number. And like I said, they are stateless. I want to say this again, network ACLs are stateless. You've got to port them inbound and outbound. And network ACLs process rules in order, so the order you actually write your network ACL is absolutely critical. So we're going to show you what not to do, and then we'll tell you what to do. Typically I do it the other way around, but I've just seen so many problems with network ACLs and ACLs in general throughout my career in networking. So let's say you have a rule 100 and they're processed in orders, and you're going to give them a sequence number. If the rule 100 says deny all traffic, and then I have a rule 110 that says basically allow port 80 or WW traffic in, both inward and outward, I've got a problem. And the reason I've got a problem is as soon as it hits the deny all traffic, all the traffic is thrown away and blocked. So it will never hit my permit rule. So we have to have things that we want to permit long before we have things that we want to deny. So now let's talk about the proper way. The proper way is simply to create a rule 100 or a rule 110 that says permit TCP port 80 source from any or whatever destination we want. And in this case, I'm just allowing TCP from everyone with a rule 110 that says TCP port any, source any, and then I'm going to allow the TCP port 80, the return traffic, to any destination, and that's it. It's going to work great. But order matters. So basically make sure you have a permit before something you need to deny, unless you need to get very specific. For example, you could deny a host on a subnet and then allow the remaining of the subnet. In that case, the order would matter too. Deny the host before the subnet. So be smart about your order. Realize that it reads in a rule. So if you've got a rule that says throw away, it'll never process to the next rule. Here in this diagram, you can see that we have a network ACL blocking access to the subnet. So now let's talk about security groups. And we find so many new students actually get security groups and network ACLs confused. Network ACLs keep traffic out of the subnet. Security groups keep traffic out of an instance. So when you're going to apply a security group, you're going to apply it to basically an EC2 instance or a service. So I just want you to understand the difference. I'm going to say it again because we have new students that struggle with this. Network ACLs keep traffic out of a subnet. Security groups keep traffic out of an instance. And security groups, when you're going to write them, you're just basically going to write allow rules because that's really basically what's all supported. And you want to basically allow whatever you need in, and the rest of the traffic is going to be denied. Now the good news is with these security groups, they're stateful. So basically you determine what you want to allow in, and it knows to allow the return traffic back out. And this is another layer of protection because if they get past your routing and they get past your firewall and they get past your network ACL, you've got the security group protecting your services. So it's part of those layers that you're going to want to use. As you can see in this diagram, you can see where the security groups are applied and we're protecting some instances. Now, layers, like I keep saying, layers and layers and more layers. So I like, and I typically recommend whenever I'm dealing with high security architectures, that the organizations actually place a host-based firewall on their servers and even their workstations, but apply a host-based firewall. And this is typically it's a lighter firewall and it's placed on the devices, and these firewalls will then act as a last line of defense on that system. So if all your other systems will be attacked, then these firewalls can actually protect the system, at least for a period of time, or maybe completely thwart the attack. And some of these can be quite significant in terms of security, but most of them are on the lighter side. But some of the commercial vendors that are used in the enterprise environment do produce some very good host-based firewalls. And some of these host-based firewalls can actually be integrated into IDS, IPS systems, but we'll talk more about IDS and IPS systems in a bit. So now let's talk about preventing a DDoS attack. And for people that are not familiar with distributed denial of service attacks, typically here's what happens. Let's say I have a web server that listens on port 80. If I've done all the other things I've described to you, the only thing that web server would see is port 80 traffic. But what if my server can process 5,000 requests a second? If someone sent me 5,000 requests a second, that would completely eliminate all that my server could do, and it wouldn't be able to serve anybody else because it would be dealing with the requests from one attacker serving me 5,000 requests per second. So now let's say I've got one hacker, and this is why that's a denial of service attack. It basically comes from one user on a system. They send whatever it takes to attack the service that I'm exposing to the internet, and it makes my system unusable. And after it's unusable, then you can then obtain privilege access off into these systems and truly compromise them. So you can take down the service, but you can use these types of attacks as a means to actually attack the servers as well and provide other types of malware on the network. So a distributed denial of service attack is basically the hacker hacks multiple systems on the internet, and then they use multiple systems to launch an attack on the server that's providing the service. And there's lots of ways that we'll talk about in some of these programs that we can prevent distributed denial of service attacks, or at least make an organization better prepared to deal with them. But in this particular case, we're going to talk about it the AWS way, because we deal with a lot of people focusing on certifications. But realistically speaking, I mentioned this, it's a full security posture to block DDoS attacks. Now, I'll address auto-scaling for a moment because it can provide some incredible DDoS protection, even though we're in the networking section. So I previously gave you a situation where I've got a web server that can handle 5,000 requests per second, and I told you I had an attacker attacking me 5,000 web requests per second. My server is going to serve 5,000 web requests, whether it comes from people on the internet or whether it comes from the one attacker. So in the process of doing this, in either case, I'm in trouble. So in the short term, what if I could scale my web server out 10 times over? So instead of being able to support 5,000 requests, I can support 50,000 requests. Well, it's going to be very hard to take my system down if you've got a good auto-scaling policy enabled. And again, you're not going to run this forever, because if you do it in this manner and all your systems are running dealing with only hackers, it's going to get very expensive. But if you've got a production system that's critical, this is a great way to stay functioning. So use auto-scaling. Now, Amazon has their own DDoS protection, and it's called Shield. And there's two versions. There's the standard version, which is free to organizations that are using WAF, and there's the Shield Advanced, and this provides protection to a lot of things: EC2 instances, load balancers, CloudFront distributions, Route 53, and global accelerators. So you can get some fairly substantial protection in terms of DDoS protection with AWS Shield versions. Now, talking about Shield Standard, I mentioned it's free, and it protects against common AWS attacks. AWS claims that it can block and protect 96% of the most common attacks, and these are your typical attacks like your SYNAC floods, your reflection attacks, and your HTTP slow reads. But Shield Standard is going to be based upon a policy, and it's static. And it's going to use that static policy that you create to prevent against DDoS attacks. Now, if we start looking at Shield Advanced, we get into some much better protection. But it is available at an additional cost, and it can get pretty expensive. But you're going to apply this on load balancers, EC2 instances, CloudFront, Route 53, and it offers more of an intelligent attack mitigation. So I typically talked about some firewalls and other devices that would be adaptive. They would look at traffic patterns and they'd say, this doesn't look right, let's create a rule and block it. Well, AWS Shield can help out with that. It can deploy like web ACLs on demand based on traffic patterns and really protect you. So it's a great service to really add another layer of security. And it gives you good visibility into the attacks and gives you some notifications for layer 3 attacks, meaning the network layer, layer 4 attacks, meaning the transport layer, and layer 7 attacks, or the application layer. And people that are AWS Shield customers have access to a 24/7 DDoS response team, assuming they have business or enterprise support. So not only does the service keep you safe, but you've got people that can help you deal with this, especially if you're not a security guru that's used to critical event mediation. And let's face it, most organizations are not used to being hacked on a daily basis. So this is really a great service because these people focus on it all day. Now, intrusion detection and intrusion prevention systems are unbelievable because basically what happens is they can look at behaviors and they can basically adapt and stop them. Now, one of the things that we find to be a great way to do this is to install the host-based IDS, IPS agent on a system. And what happens basically, you've got a manager, and the manager is responsible for managing the local systems or the agents. So you install the software on the server. The server will send traffic pattern information to the manager, and the manager will just watch what's going on. And if everything's going on as well, things are going to be perfect. They're going to run smooth. But if all of a sudden a server starts behaving funny and another server starts behaving funny, that IDS, IPS system will detect the intrusion and it will stop it. It'll create rules on demand. So very useful to have intrusion detection, intrusion prevention in your systems. And I mentioned a little bit how you've got the host agent and then you've got the manager, which is the smart device that actually controls the host agent. And they can do a couple of things. I mentioned they can heal themselves. They can basically look at the packets and say, these don't look right, and drop them. They can basically block a source address. They can say, oh, this traffic's coming from one hacker, let's block it. They can reset the TCP connection, or the connection that you would have between the hacker or the device that's trying to attack you, and basically they can't attack you anymore. But it can also send you some alerts, and if you've got some good alerting capabilities, you know what to do. So let's talk about what we talked about. We talked about routing to control who can access your network. And then we talked about using firewalls to keep unwanted traffic out of your network. And then we talked about network ACLs to protect your subnets. We talked about protecting your instances with security groups. And then we talked about further layers of security like host-based firewalls and IDS, IPS systems. And we talked about prevention of DDoS attacks with the various forms of AWS Shield. Please remember, we have a free AWS Certified Solution Architect Professional exam. It's free. Please download it. The link is in the description below. We also offer free weekly mentoring for AWS Solution Architect students. Please see the link below, but realistically what happens, you'll fill out the form, you'll send us whatever questions you have, and then in the next week what we'll do is we'll do a meeting via YouTube Live and we will answer everyone's questions. I remember when I was studying things before I could afford training, I'd read a book and it was very challenging. I'd read certain things and I just didn't understand them. Or I took an e-course and it was one of these slides plus audio that are really hard to watch, and I've done things like that. And then there's things that you're confused on. Well, we don't want anybody confused. We don't want you to have to Google all day and find 14 answers of which one is right. So bring your questions to us once a week for 90 minutes. We'll answer them, and the link for that is in the description below. We so much enjoyed giving you this presentation on securing your VPC, and we look forward to discussing more VPC security options with you next week. Thank you so much.